Hi and welcome to my maths class. Today we are doing geometry, but there are a few parts of geometry. Number one is where we do a proof. Number two is where we do application of the proof. When you're doing riders, you'll use multiple theorems to prove that rider. But when you're asking the proof of a theorem, it would be standard that you already know and you've already seen. All in all, in grade 11, it can go up to 9 theorems. Sometimes they join the theorems and you have 8 theorems, but they are up to 9 theorems. And from the 9, they usually ask 2 in the matric exam. So in your final matric exam, they're most likely going to ask 1 or 2, which is an easy 7 marks or 14 marks or 10 marks in the bag. So you must learn these proofs. Now, when you're learning these proofs, you don't learn them as theorem 1, theorem 2, theorem 3. That is not what they're called. They have names, and if you learn the names correctly from the beginning, that is what you'd use in the riders and you get the correct marks. If you use the incorrect names, like if you're using this theorem that we are doing now, and you say it's theorem 1, there's no mark allocation to it. The correct name for this theorem that we're doing is called midpoint chord. So if you were going to refer to it in the riders, you would have to say midpoint chord. You won't have to write down the entire theorem. Now let us go to the theorem. What does it say? It says if a line is drawn from the center of the circle. So number one, we know that this is the center of the circle, to the midpoint. So they're telling us that this line is going to the midpoint of a chord. Now we've discussed a chord in our previous video. If you are not familiar with that, it's advisable that you go to the video introduction to circles and go over what is a chord. Now a chord is a line that's going from one end to the other end of a circle. But what is emphasized here is that it is going through to the midpoint, which means it is cutting this line exactly in half. So we have 2 halves there. Now when we're doing the proof, you will see it's a standard form. They usually start with given. So what were we given? What have we just discussed? We were given the center and we were given the midpoint. What do we want to prove? We want to prove that OM is perpendicular to NL. Now remember, the drawings change, the alphabets change. You must get familiar with the work. You mustn't get comfortable with the alphabets we use or the alphabets in your textbook or the alphabets that your educator tells you about, because at any time they can change it. PQR, NMO, LOP, Q, it doesn't matter. They use what they want to in the exams. So there's no fixed alphabets. So you must remember, I'm talking of the line from the center and I'm talking of the chord. OM is the line of the center from the center and NL is the chord. So that's what I want to prove. That's what I want to prove. How do I go about doing the proof? Now these are the steps that I'm going to do. Number one, I'm going to construct, right? Construct means in your proof, you're going to add lines, right? Construct. You can only construct in a theorem. You cannot go and construct in riders. So when they're giving you a question and it doesn't look like any of your theorems, you'll see it with many lines or different. It doesn't look standard. Like maybe if you look at this, it's a rider. You can see it's many circles, it's got different numbering, different alphabets. You can only construct in your theorems. Alright, so what are we going to construct? We are going to construct the line OL, ON. Right, now if you look at that, if you are familiar with the circle, we drew a line from the center and we're going to a circumference. Now we've discussed this in our previous video where we're doing introduction to circles. Those are called radius. That is what they are called. So these two lines that you have constructed, they are radii, plural for radius. They, ON is a radius and OL is a radius. Now let us go on. If we take in triangle OMN and triangle OML, what do we have the same? Number one, we have that ON is equal to OL. Why? They are both radius. Right. Then we have that OM is equal to OM. It's common. Common means it is the same one in both the triangles. OM is in the one triangle and OM is in the second triangle. Then we have that MN is equal to ML. Why? This was given to us. In the beginning they had said that the circle to the midpoint. So it was given to us that that's the middle, making it equal. So what do we have now? We have that these two triangles are congruent. Congruent meaning they are exactly the same. We had done congruency before. You would find it in our grade 10 work. So if you are not familiar with congruency, then you need to go and get the grade 10 syllabus and look through it, because it is actually coming into our syllabus at grade 9 revision level. So congruency is done in grade 9 and you would find it in our grade 10 revision videos. So why is it congruent? Side, side, side. If we have that they are congruent, we can say that this angle, which I'm going to mark M1, and this angle, which I'm going to mark M2, are exactly the same. So therefore we have that M1 is equal to M2. That is a deduction you get from congruency. If the two triangles are exactly the same, that M1 is equal to M2. But M1 plus M2 is equal to 180 degrees. The reason being is angles on a straight line or adjacent supplementary. Now adjacent means next to each other, supplementary means they equal to 180 degrees. People use the rule angles on a straight line, which is also valid. Adjacent supplementary is more correct. Since M1 is equal to M2, that would mean that 2M1 is equal to 180 degrees. If we divide by 2, we have that M1 is equal to 90 degrees. Likewise, M2 would equal to 90 degrees. Now, since M1 is equal to M2, which is equal to 90 degrees, we have now proven that OM is perpendicular to NL, which is exactly what they had asked us in the beginning to prove. Thank you for watching.